Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are again back with our next problem of the day. Hi, Madbar. Hi, Risit. How are you all? Please first let me know if I'm clearly audible and visible to you all so that we can start with our class today. Am I clearly audible and visible to you all? The problem we are discussing today is Bheem wants Ladoos. Okay, and it's a problem of binary tree. So let's have the problem. First of all, please confirm me if I'm clearly audible and visible to you all so that it will be better for me to start. Okay, great, Rishi. Thanks for confirming. Let's start today's class, guys. The problem we are having today is Bheem wants Ladoos. The problem is very simple that Bheem wants to eat maximum number of Ladoos in Dholakpur on Independence Day. The houses in Dholakpur are arranged in a form of a binary tree, and Bheem is standing at his house and the home house is given to you. All the values are distinct. Okay, what you do is that Bheem can go at a maximum distance k from his house. Bheem can go at a maximum distance k from his house. So you have to tell what is the maximum ladoos he can get if he can go to the houses within a maximum distance. Okay, so let's take a house that is given to us. Let's take it. Just a minute. Okay, great. So yeah, so let's take the houses are like this. Okay, so let's say this is the binary tree given to you, and guys, they are asking from you is that you have to find. Let's say the home is. Let's say the home is simply. Yeah. The home we are having is, let's say, at 5, okay, at 9. So we cannot have, I think, distinct values. So let me erase it. Let's say it's 16, it's 12. I think 5 is also repeated. So let's, okay, 9. Let's say k is given as 1. Okay. So what it is saying is that there is Bheem who is standing at his house. Let's say his house is at 9. Okay, standing at his house. So what there is given is that, what is given there is key, you have to simply uh, find कि from that house you can go at max distance k. Like if k is 1, means you can go at max k houses, like 1, 2, 3. So what is the maximum sum of all the houses that you can go? Okay, maximum. Hi, Henrik, hi. Okay, that is what we are having. Fine. So what we'll do is, guys, obviously it is a tree problem, so we'll be using recursion for the thing. Okay, we'll be using recursion to solve the problem. How we will use the recursion? So guys, what we will do is, what we will do here is, let me open the code editor part. Okay, this is the root given to us, and this is the home given to us, and k given to us. So guys, first of all, I will find the home. कि home कहाँ पर है? Okay, first of all, I will find the home. कि where that home is present actually. Okay, and when I will find the home, what we will do, guys, कि from that home, I will go at k distance at the top and in both the child, and up to k distance we'll be having the sum. I hope that's completely fine. Okay. So what I will do, guys, what I will do here is, I will write here. I will write here a recursive function. Okay. Let's take a recursive function like this. Let's say that the recursive function name is simply traverse, because through that function will be traversing through that thing. Okay. So I will have a function traverse, which will help us to traverse through the whole tree. Okay. Now I will have that particular node n, the current node where we are. Okay, we'll have a target. Target means, or I can say the home. We'll have the home. Home means where we wanted to know, where we wanted to go. We wanted to go to home, na? हमें home पे जाना है. That is what I am saying here, home. Okay. Now I will have the value k, and guys, I will have a sum here, and I will have the reference of sum, so that every recursion call has its own sum. Okay, great. Now guys, see what we'll having is, okay, I will call this function here, and whatever answer this function will return will be the answer for our case. Okay, so it will be like this, and initially I will take, like if you want, initially I will take my sum as 0. So like I can take here a sum, and because I'm having a reference here, I have to also pass it using the address operator as the AND operator. Okay, asterisk. Okay, so that is what we have to do here. Now, guys, let me tell you what we have to like now do here. So we'll be in this particular program. We have first a base case. The base case will be that if my n is null, in that case simply return minus. Now, why I am returning minus? This means that if my n is null and if I'm returning minus 1, that simply means ki sum is not possible. Sum is minus. Okay, no such sum is possible. Now, if the current number, the current data is equal to our home, like the current node where we are, if that node is equal to home, I will say if current node is home, then what I will do? So guys, if the current node is our home, so हम क्या करेंगे? Okay, wait, 1 minute, guys. We will not return this traverse. We will return the sum, na? Sorry. So we will return the sum. So sorry, guys. हमें sum return करना है, the total sum, not the traverse or not that particular nodes. So I will return the whole sum. Okay. Now see, guys, what I will do. If the current node is equal to home, if our current node is equal to home, so what I will do? I will take the k nodes from it. I will take nodes up to distance k from it. So for calculating that distance also, I will create a function. Let's name it. Let's name it distance sum. Let's name this function as distance sum, and this function will do nothing. This function, the task of this function is very clear. It will simply calculate or find the sum of nodes which are up to k distance from that particular node, up to k distance, and I will store that sum in this sum given sum. Okay, so see, if my node is null, like this is the base case for this problem. If my current node is null or my distance is 0, if my current node and my distance less than 0, got it? If my current node is null and k is less than 0, means we cannot take any more node, I will simply return. Else what to do? Else what we'll do, guys, because let's say I'm here, let's say, yeah, and k nodes from home, exactly Madhur. Okay, so let's say, guys, my home is here, so like I have got the home, and whenever I've got the home, I will call this particular function this sum. Okay, now if let's say if I'm here and I have to find the sum of k nodes from that home, k nodes from that home, k nodes from that home, so what will I do? So what will I do is ki I will check for both the children. I will go here also, left children also and right children also, and I will add them. I will add the right children also, I will add the left children also. Or let's say what I will do, I will add this same node to in the sum, and I will go for the right and left children. Okay, so like if my k is also not equal less than 0, and if my node is also not null, what I will do, simply in the current sum I will add my node data. In the current sum I will add my node data. This is the sum, but if that node is there, yeah, like it's something like that only, but then also we have to make some changes now. See what I'm doing. We are doing very simple. I am calculating this sum, and it is taking a value k. K means how much distance we can take. How much distance we can take. So if k is less than 0, or if my node is null, simply return. It's not possible. But if k is not less than 0, that means we can take that particular node in my sum. So I'm simply adding that particular node in my sum. And then what to do? Then I will first go for the left subtree. I will first go for the left subtree. So which will be simply n left k minus 1. Now distance will be k minus 1 for the next and sum. And similarly, I will go for the right subtree also. I will go for the right subtree. See, the time complexity is going to be order of n only. Okay. Got it? This is the thing. Now, so whenever I will get a node which is equal to my home, means my current node is my home. So I will simply call for this function this sum, okay, with the value of n, k, and sum. Simple. And I've returned k minus 1. Why? Means for that particular node I've taken, and rest of the nodes are written. By the way, it is not required. It is only required to know. क्योंकि देखो जब n null है, when n is null, so -1 return कर रहा है, and -1 specifies कि that particular node is not present here. So now, if my current data is equal to home, it's fine. But what if my current data is not equal to home? So what I will do, I will check for a left subtree and a right subtree. So first I will check for a left subtree. First I will check for a left subtree. So let's say I'm saying left, or let's say it's L. First I'm checking for left subtree. So I will call the same function traverse for left subtree having n left. Okay, and everything will be same. Like home will be same, k will be same, and sum will be same. And let's say the home is present in the left subtree. How we will know that home is present in the left subtree? If my value is greater than -1. Because देखो, if it is not present, your value will be -1. If home is not present, your value will be -1. But if home will be present in that particular node, in that particular side, so it will run k minus 1. So if my value of L is greater than -1, means home is in left side. Then what will I do? Then what we will do, guys, that if home is in the left side, I will add the value. I will add the current value in the sum, and I will check for the left side. So if we know that the target is, or the sum is found in the left subtree. So what I will do, I will add it, and now we will go for the right subtree. Check this thing in the right subtree. Because we know that left subtree mein the home is present. But for the remaining part, we will check for right subtree. And if we return the value of k minus. Sorry. Okay, it's L na. Okay, it's L. So it will be L minus. Exactly. And guys, similarly, just like we are doing this thing for the left, we will do the similar thing for the right. We will do the similar thing for the right only. No, right के लिए भी similar thing करेंगे. And if it is present on the right, I will take for the left. And else at the last also I will return -1 that it is not present. That's all. That's the simple thing that we are doing here. So if you will see here, if we will run the code. So simple क्या था? Simple we are first searching. Simple क्या था? We were first searching for a node. Okay, k was not declared. Where? Okay, sorry, it should be int k. Yeah. So our first thing was we were doing nothing. We are just first searching for our home, and whenever our home will be there, we will go and we will be giving or we will be checking the k nodes from that home. That's all. Okay, what happened? Okay, there should be a comma. Okay, so we have got the answer. If you guys want, I can also, okay, so it is submitted successfully. If you guys want, I can send the solution to you all. So take this thing. Here is the C++ solution of what we have done now. Yeah, so this is the C++ solution of what we have done now. Okay, so the time complexity and space complexity is like no as such space we have taken. It's simply a recursive stack that is being used, and its time complexity is order of n only, where n is the number of nodes, because we are it's a type of traversal only. If you will see, it is a type of traversal only. So that's all what we're doing. Okay, so guys, I hope that you have so find the home and then take sum of all node distance from exactly this exactly. If you use before the problem is need find the value home and so traversal size k. If you use BFS solve this problem, his need find the value home and so traversal size k. Yeah, it will be exactly, it will be k, but for finding the home you have to iterate through the whole tree, so it will be ultimately order of n only. Okay, great. Okay, so great guys, I hope that you have got this particular problem. Let's meet again tomorrow with the next problem of the day. Okay, till then, happy coding, bye bye, take care. GFG कर लो, हो जाएगा.